cup and had the scotch next to me for when I run out, because Brodo's going to burn quite a bit, apparently.
So what we're starting off with is that Brandon already needs more alcohol for the show, is what...
Well, I still have tequila left, but I don't have mixers for said tequila. So, hi.
Hello, everybody.
Hey, Suzanne's here.
We are back. We are live, and what's great is that Brandon and I don't know what the show is going to be about. Well, we know what it's going to be about, but we don't know what's going to be included because Mike has kept everything secret. So we'll.
And I'm ready to argue about things, I think.
You want to be argumentative? You're just going to be.
I got my number one. I think I got my number one in.
Okay. All right. Well, we'll give that extra little preamble as well when we begin it. Well, I'm not looking at the iPad.
Because a little bit of it shows up at the bottom.
Hold on, Jack's making food. I gotta focus. Probably the bacon wrapped asparagus.
Ooh, that actually sounds
with
good.
fresh lemons from his own tree.
Look at Susanna putting on so much pressure.
I mean, I'm gonna make pasta with bacon in it tonight.
Yeah.
Made some good turkey burgers yesterday.
Ooh.
You just ignored what I said.
What?
Susanna putting all this pressure on me. Been looking forward to this episode for weeks.
No pressure.
All right.
Pressure.
We ready?
Nope.
Am I ready is the question.
Are you ready?
Hi, everyone. Welcome to another edition of Cosmos. As always, I'm Mike.
I'm Liz.
I'm Brandon.
Yep. And today, Mike's top 10 astronomical discoveries. There's going to be some caveats to this. There's going to be some criteria that I had to put down.
So this is all subjective. This is based on Mike's opinion and not a formal designation of the top 10 astronomy discoveries, but
and
should be some good ones.
My opinions do not reflect the opinions of Cosmos or its parent company. Or CEO. All right. I mean, we're going to talk about, 10 discoveries. And to be honest, this is a list of 10, but I had at one point 18 items on it.
Ooh. Was it like Eurovision when you give like one person the rose and they have to leave or something like that?
Yeah, pretty much. All right, Brandon. What are you drinking?
Oh, that's a good point. So I am drinking the Achernar, which is apple, cinnamon, cranberry, orange juice, tequila, and crushed blueberries.
Ooh,
well, that sounds
that's
really
like a
good,
nice
actually.
fruity.
You're gonna have to send me that list again.
Well, it's really just one juice that has most of those things, but still quite nice.
Okay.
All right, and I guess.
Well, we're kind of drinking the same thing, although I want to call mine one of Quark's Bar's top 10 drinks.
Oh, okay.
Kentucky Bourbon Peach Tea, which I've been adding the Kentucky to this title
and
by myself
this
whole time.
And leaving off the sweet in there.
But it's basically peaches, peach iced tea, bourbon.
Peach schnapps, lemon juice, and brown sugar.
Ooh.
So also
dangerously peachy.
It is. It's dangerous drink.
And I have the same drink that I'm calling the Spherical Bastard.
Okay.
That's not the first time I think
that's a good classic.
Yeah, this is one of Katie's favorites drinks.
Yeah,
as well.
it definitely is. I put it on the list once, and now I can't take it off. It's basically Katie's drink. All right. Follow us on all the things. Twitter, because I will not call it anything else. Drinking Cosmos. Everything else is Cosmos with Cosmos. And so follow us, rate us, wherever you get your podcasts, all that kind of good, fun stuff. Don't forget to join us for the Hangover. That will come right after this. Apparently, we're recording shots later today, so I have to go get other material. Because Liz has told me that she doesn't want what I brought out. Anyway.
I never said that. I said we got some other cream liquor we need to get rid of.
My shots would be aguardiente, and I'm very excited for it. Love aguardiente.
All right. Of course, we have a lot of friends of the pod. And,
friends of the pod.
And if you're ever on Etsy, check out Wildixia. Ixia. Katie has some really great, amazing stuff, and I will always be happy that I was the first one to buy something from there. I beat you, I beat your whole family, and everybody else. Anyway,
yes, you win.
I'm not bragging. Also, if you happen to be on YouTube, check out the Real Mr. Proctor show. Our good friend Ron Proctor, he did some music for us. For this.
And hopefully they happen to be on YouTube because we're also on YouTube.
yeah, but they're there to watch Ron. Not. Also, if you're in the Council Bluffs area in Iowa, southwest corner, Jack, let me know if I have the geography wrong. But southwest corner, check out Rolling Bus Planetarium. You can tell them that Cosmos sent you.
So
you don't get anything. You don't get anything at all. But anyway, Jack will give you a tour of the universe and tell you all about the wonders of it.
Or just, whatever her show lineup is.
Or whatever. And if you do want to check out what they are showing, rollingbluffsplanetarium.com. All right. And as always, they have rules. I'm trying to really keep this iPad. I know, but I just feel like we have rules. If a puppy barks, and apparently Mr. Frodo will be barking.
Yeah, Mr. Baggins is in a bit of a tear. He already barked once during this. I don't know if you heard that.
Oh, we did not.
Yeah. My sound suppression is doing real good.
Okay.
But he is running all over the place right now.
All right.
Oh, buddy.
So, if dog barks, take a drink. If there is a Star Wars reference, take a drink. And, of course, Lord of the Rings. Take a drink.
The Lord.
Buddy.
All right.
Our Lord and Savior of the Rings.
Now, before we start listing these things, I had to set up some criteria for it. And so I'm going to go over that really quick.
Yeah, because otherwise you could just get bogged down, rabbit holes upon rabbit holes.
Really quick, I realized I was going down some rabbit holes with stuff that I wanted to do. So
some black holes.
All right. So the criteria are, it had to be an observation. So no theory.
Okay.
So sorry, Newton.
Oh.
Sorry, Einstein.
Oh, man.
It doesn't mean that theory doesn't show up. Because I will talk about it. But observation. So it had to be things that were observed.
Oh, okay.
Had to be confirmed. It could not be, hey, I saw this. I'm the only one who saw it. So it had to be something that was concerned.
Okay.
It also had to be astronomical. Sorry, Quarks, because I was starting to go down that rabbit hole too.
Of course you were.
And also, it doesn't mean that there's not any overlap, but it had to be astronomical, and that helped prevent me going down those rabbit holes, like I said. And finally, it had to fundamentally change our idea of the universe or our place in it, and or push technology and theory to the boundaries.
Wow,
so,
this is pretty comprehensive.
Right.
Oh, did we bark?
Mm-hmm.
You know what? We can't hear it. Your noise suppression is
love that.
Doing good.
I'll just drink then.
Every time Brandon drinks, it's because Frodo's barking.
Okay, are we ready to do it?
Let's go into it. Top 10.
Number 10, Uranus and Neptune.
Uranus and Neptune.
Yes. So we're gonna go back in time.
We did. Doodaloo.
Not too far.
I guess
not
we
too
did
far. We're not gonna go too far back in time. We're gonna go back to 1781 for the first one. And
nope. I gotta get these buttons down. These buttons are.
And let it be known, you did not see any of the pictures.
I did not see any of the pictures that we are showing.
All right, so I decided to combine these two. They are similar, not only physically, but they are related to each other in their discoveries.
They're a little, they got a lot of methane.
Yeah. And so let's begin.
Oh, our camera is frozen.
Mm-hmm.
Cool. That's cool.
I can act out the rules of everyone. Okay. So
all right.
Okay.
So 1781. William Herschel makes a discovery. from his garden in Somerset in the UK. So he found Uranus. Interestingly enough, a lot of people had spotted Uranus prior to William Herschel's discovery, but they usually always thought of it as stars and stuff like that.
It's nothing, just a whiff of clouds.
Well, now we have to. I have to find the right drink button here.
He initially thought it was a comet, so initially he didn't even think it was a planet. And after his discovery, it wasn't even him that was the first one who thought of it as a planet. He, for a couple of years at least, thought it was a comet. So he reported it on April 26, 1781 as a comet.
This was Herschel, right?
William Herschel.
Well, he's got a thing for comets, so.
He does. Anders Johann Lexell, who's Finnish but working in Russia, was the first to calculate its orbit. He determined it was nearly circular and determined it as a planet.
Hey.
Yes.
Hey.
Just by math.
But William Herschel still sticking with
comet.
Still sticking with the comet. In 1783, it was finally just generally accepted as a planet, even by William Herschel. And so
his toughest critics.
Yes. King George III.
Yes, that bastard.
The Mad Monarch gave Herschel a stipend of £200.
Oh.
Now, if you're wondering what that is today,
yes.
$51,000.
Damn it! Wow.
So that was an annual stipend, and it was on the condition that he moved to Windsor Castle so that the royal family could look through his telescopes.
I got paid £51,000 a year, so people just use his telescope. He got to live in a castle.
For more on that, check out our episode on William Herschel.
Hey!
Yes. All right, so Uranus is a planet. At that point, we now have 7 planets in the solar system. That was the count at the time, but the solar system was not done yet. And so...
For another planet was formed.
It was perfect.
It was right there. I'm sorry.
All right, so Neptune. So gotta get into its story now because it's tied to Uranus. In 1821, Alexis Bouvard published tables on the predicted location of Uranus for future dates. Yes,
we like to know where the planets are going to be in the future.
Exactly.
You know, we like to keep track of them.
He used Newton's equations to figure it out, and they found quite quickly that Uranus deviated from that.
Oh,
deviated
and so,
Uranus.
1843, John Couch Adams started working on the Uranus orbit problem.
The Uranus orbit problem.
It's glorious.
It's a UOB.
Independently, Urban Le Verrier started working on it too. You can check out a shot on Urban Le Verrier. Le Verrier published his data, closely matched Couch's data. So a guy named James Chalet started searching for it in 1845, but poor observing techniques and a desire to find comets meant he failed to recognize, even though he friggin' saw it.
Oh, God. That's gotta really
not on one, but 2 occasions.
Oh, I would just
anyway,
drive me crazy.
Le Verrier sent a letter to Johann Gottfried Gale in Berlin with where he thought Neptune would be, and Gale found it that night.
He was like, "Hey, I think it's right around here," and he was like, "All right, let me just," and then they're like, "Oh."
So, Neptune discovered. Uranus discovered by one of the greatest observational astronomers.
Hell yeah.
William Herschel. And Neptune discovered by mathematicians.
Mathematicians. That's great. I always love that. I mean, I wouldn't be discovering any planets by math.
All right.
There's no way you guys didn't hear that bark.
No. Oh, was that a bark? I thought something like...
Yeah.
Okay, that one we did hear, but it didn't sound like a bark. So drink if you want.
Cool.
Drink if you got it. I only just took a sip, so... You know what? It would be great if like the Hershey's was around at the same time Herschel was, because then Hershey's kisses.
Oh yeah.
And you can make like a whole little like. Anyway.
Hershey's.
Number 9. Exoplanets.
Exoplanets.
All right, very planet heavy so far. Not bad.
Yeah.
Well,
yeah.
you know.
All right.
They're pretty good discoveries. These exoplanets.
All right. For this, we did not have to go as far back. Just 1992.
Okay.
Oh, ancient.
Okay.
I was working at the Melton Observatory in Columbia, South Carolina when this came down. Obviously, I was not involved in the discovery of these things. But it was the first exoplanets discovered, the pulsar planets. There were 3 at the time it was 2. They saw 2. And on January 9th, 1992, radio astronomers Alexander Wolfson and Dale Frail announced the discovery of 2 planets orbiting a millisecond pulsar called PSR 1257 plus 12. And so what they noticed was as the pulsar, they didn't actually see the planets. They saw its effect. Yeah. And so the pulsar spins very quickly, millisecond time, but it would speed up, it would slow down. It would speed up. So
there was an element of drag there.
As the planets go around it. And so they knew something unseen was there. They did some calculations. They figured out there were 2 planets.
It's just like Neptune.
Yeah.
Yeah. So a couple years later, 1994, a third was added to it. And so it had 3 planets. And it was like, basically, astronomers were like, what the fuck?
Yeah, pulsar with planets.
Yeah, this was not what they were expecting to find because the supernova would have destroyed the planets and most likely did. These are second-generation planets.
Which is so cool.
Yes.
Like, how wild would it be to have like a pulsar as your star if you were...
It would not be
deadly.
Good. It would be deadly.
Well, you know. Well,
radiation.
Maybe you could...
We don't do well with radiation.
No, but maybe something out there has made like some fucking shit to, I don't know.
Radiation-based life form.
Yeah, you don't know.
This pulsar is 2,300 light years away in the constellation of Virgo.
Hey!
But, we want to continue to look for planets, right? We want to find something that's a little bit like us. Not something that is completely...
Like the Earth, maybe not like us.
Crazy, like a pulsar. And in 1995, we found a planet around a Sun-type star, 51 Pegasi B.
Hey.
Let me guess. In the constellation of Pegasus?
It's actually in Aquarius.
Oh, what the fuck? Astronomers?
It's in Pegasus.
Oh.
Wow.
You totally...
God, you took that so seriously.
Your delivery on it was just like...
See, I made the joke, and then Mike said it with such conviction. I was like, oh shit, maybe he is right. Maybe he wasn't in there.
No, it's in Pegasus.
Oh, God, okay. But, I mean, sometimes they do that where it's like...
Yeah, but this also was a one where it was like, what the fuck is going on? It's a hot Jupiter planet. So the planet going around it, very, very close to the star, the size of Jupiter.
A good time, 1-800-HOT-JUPES.
Hot Jupes, yeah. And so... Yep. And so, that's where... What's crazy is I actually have in my notes 50 light years in Virgo. I wonder if that's because I have Virgo in the other... It's about 50 light years away, but it's in Pegasus.
It's not too bad, not too far.
Oh, no. It's picked up our radio signals. It's watching whatever we were watching in the 1970s.
That's picked up our radio signals and are like,
MASH.
Avoid that place. We are not stable.
It's watching Starsky and Hutch and... All right.
Actually, no, at that point, they got Star Trek.
No, well... 50 years ago, 1970. Star Trek was in the 60s, and then the Next Generation was in the 80s, right? The 90s?
Yeah,
they would
88.
They would have OG, though.
They would have OG if they recorded it.
You would think that these aliens would invent VHS by now.
Yeah.
So they're good. They got it.
All right.
They got it.
Because that way they'd be recorded on tape.
Joke's on all the streaming. Oh, no, the streaming's not doing radio waves. I was going to say, they get all their TV for free from us. Stealing all the TV.
They're stealing our passwords. All right. 2016, a family of planets were discovered.
Oh.
TRAPPIST-1, 40 light years away in the constellation of Aquarius. 7 planets around a cool red star. All 7 of them are within the orbit of Mercury, so within 40 million light years of the star.
Yeah.
Very close, but it's a cool star.
So it's smaller.
So 3 of them actually reside in the habitable zone of the star. But as we have said a few times, red stars, temperamental.
Oh yeah, they have little outbursts occasionally.
Yeah,
they have a little Napoleon complex. Yeah.
But 3 or 4 of them in a habitable zone. As of right now, I meant to look it up earlier today, but as of yesterday, Saturday the 17th, when I was putting in some of these notes, 5,903 confirmed exoplanets.
5,000. Do you guys remember when it was like 3,000 and we were like, oh my god?
I remember the big jump that Kepler released. Suddenly we went from like 60 planets to like 1,600. It was an amazing day.
Yeah.
Oh man.
You can find out more about it at the NASA Exoplanet Archive if you like.
Yeah.
Number 8, black holes.
Oh,
wow!
Black
Number
holes,
8
number
for
8.
black holes. That's surprising, given.
But so far we still have lots of round objects going on here.
Lots of round objects.
I mean, I think that's what we're gonna find in a lot of these things.
The round.
Yeah. So, it's not.
That's the lowest energy state.
I do kind of have it broken up into
like
two parts. But
it's like me most days.
All right, so black holes. For this, you do have to go back to 110 years to Einstein. Cannot have black holes without Einstein.
I know you want to do it.
I want to do it.
Einstein's theory of gravity is a general theory of relativity.
Yeah.
It basically results in how mass and energy warp space and time.
I don't think anybody's familiar with that.
Yeah, we haven't talked about it.
It's a complicated equation, I think, as well.
I got it somewhere.
It's inelegant.
Very elegant. Basically, mass tells space-time how to warp.
Susanna in chat says, I'm remembering the black hole shows you would do at the Science Center. 5-year-old her thought her fate would end in a black hole. Scaring your children to death. Mom.
So basically, mass tells space-time how to warp. Space-time tells the mass how to move in it. I could fill a whole episode of 10 proofs of general theory of relativity, but some of them are the precession of Mercury, the bending of light, gravitational redshift, binary pulsars, gravitational waves, frame dragging, gravitational lensing. And so those are all proofs of...
Frame drag? This sounds like a Digistar issue.
Yeah, sounds like somebody answering a ticket right now.
No. Gosh, our camera paused again. What is going on with our camera today? This is going to drive me
I don't know.
crazy.
Anyway, so that's released in 1915.
It's okay.
Are we still good?
Yeah, we're fine.
Oh, okay.
Still frozen.
We're fine. I know, we're frozen, but we're going to come back. We're going to come back.
In 1915, at the end of 1915, Carl Schwarzschild provided the first exact solution to the Einstein field equation for a spherical non-rotating mass that has become known as the Schwarzschild black hole. These things do not exist in nature because everything spins, and these do not spin. But basically, in the solution, he identified a distance where no known force or pressure could stop it from becoming a singularity. And that distance is the Schwarzschild distance. All right, so that is the theory. They had to then look for these things.
We had to find it because...
We got to find it.
I mean, but it's pretty tough.
Took a while.
I mean, yeah, because it's not... You can't... I mean, all light. It doesn't emit... And we see by light.
Yeah, so...
So how the fuck do you see this black hole?
Exactly. And you have to see its effects around other things. With other things around it.
Yeah. It's like ghosts.
1964... X-rays were discovered in Cygnus, and so they had
constellation?
What?
The constellation?
The constellation. Okay. That's
Virgo.
Basically, NASA launched a rocket.
Cool.
As they do sometimes.
And it went up, detected some X-rays, and
came back down. It was like,
yeah.
All right, I'm done.
So they didn't really know what those X-rays were, but they did eventually figure out that it was part of a binary system where there was a massive blue star going around an unseen companion, and basically that unseen companion is pulling off material, and that is creating an accretion disk, which is the source of the X-rays, and that is what that rocket saw. But it took a while for it to be classified as a black hole.
Really?
Not just the evidence wasn't there. It started to actually the evidence really started to come in for it, to the point where Stephen Hawking and Kip Thorne had a bet about it.
A gentleman's bet.
Yeah, where one of them would get a gentleman's magazine, and I don't know what the other one was going to get.
Wait, who was getting the magazine?
Kip Thorne got the magazine. And Stephen Hawking had to pay up on it. But anyway, in 1990, it officially was designated as a black hole, the first black hole.
Ever.
Ooh. Yes.
In the universe.
In the universe.
Yeah.
But in 2019, a little project called the Event Horizon Telescope took a couple of pictures and took a picture of...
That easy.
It's just,
so easy.
It's so easy.
So
M87, which is a big, huge elliptical galaxy, has a black hole in the center of it. There's this incredible Hubble picture where it shows the galaxy and this stream that comes out of it that is...
Black hole farts.
Pretty much, yes. And then Sagittarius A star, which is a supermassive black hole at the center of our galaxy. The Event Horizon Telescope took a picture of both of those. Basically, it's a really big global network of radio telescopes. And
using some interferometry?
Yeah.
BLBI.
Yes. And it actually was as if general theory of relativity needs more tests. It was a test of general theory of relativity under extreme conditions, because relativity predicts a shadow on a dark shadow-like region caused by gravitational bending and capture of light. And so there's a shadow, and these pictures show the shadow.
The shadows of Mordor.
Yeah. Interesting. Oh, man.
I was saying Shadows of the Night, but that's good too.
Shadow Realm in Elden.
No, she's not always positive.
Catching her on a good day.
Hey.
Oh, God, don't take another drink.
I'm almost out.
Oh, where is he? In the middle of the night? All right. Okay, continue, and we'll find more about...
Interestingly enough, Einstein did not believe in black holes.
Oh, Einstein.
Yeah, he thought they weren't a realistic scenario and were outside proper physics.
Oh, he's
it's
in
just a hole in the universe.
Oh, he's in...
Hi, Elizabeth's brother in Qatar. Qatar?
Hey.
Qatar?
Whatever. You handing out planes? Are they handing out planes over there?
Well, black holes, to be fair, are hard to think about.
They are very hard to think
Holes in
about.
the universe. What the hell is that about?
You want to know what else is hard to think about?
Wait. Oh.
Go ahead.
Okay. I was going to make a bad joke, but let's go on.
What else is hard to think about?
I don't know. That's what I was trying to think about. And suddenly, that's the thinking is hard to think about.
Number 7. Gravitational waves.
Ooh, right in the waves.
Get some LIGO action.
2015. Again, these were a prediction of general theory of relativity. It took us 100 years to find it. There was a lot of indirect evidence.
Because we needed technology to find all the things that we had the time to think about when there was no TV.
Yeah. There's a lot of indirect evidence for gravitational waves. Basically, energy loss in a binary pulsar system and causing them to their orbits to shrink.
Yeah.
So clearly something is taking away energy, orbital energy. That would be gravitational.
And then sometimes they go
Yep, exactly.
Big particle.
In 1974, Russell Hulse and Joseph Taylor found some examples of this, and so there's been a lot of evidence, but you need direct evidence.
Yes.
And LIGO, the Laser Interferometer Gravitational Wave Observatory, in Livingston, Louisiana, and Hanford, Washington, were specifically designed to get that direct evidence. It's basically these two lasers that point 90 degrees away off from each other, and
oh God, Ron, there's so many top tens we could do.
Yes, and so they are in sync with each other, and so actually
detecting ripples in the pond of the universe.
They're actually, what it is they're completely out of phase with each other, and so basically they're like if a gravity wave is not coming through, you don't see anything. Gravity wave comes through, they stretch. So one leg of this will stretch, the other will contract.
So
you see a blip of light.
Ah.
And so
like a slinky.
Yeah, and so that's exactly what happened. On the 14th of September 2015, LIGO detected a ripple in space-time caused by the merger of two black holes 1.3 billion light years away.
And so, but this, these events, I assume, they have to be orientated in a certain way to catch these ripples, right? Because I feel like these events are happening... Are large enough events happening frequently throughout the universe?
Well, gravity waves are always going through you.
I guess so.
Most of them are too small
too light
to detect.
And two black holes would be a pretty big.
Yeah, in fact, Einstein thought that they would be too small to detect. And
yeah, we'll take that, Einstein. We got lasers.
And even if it's not oriented correctly, it still is going to get out of phase from. And these two observatories they have to take into account trucks driving down the interstate. It's so sensitive it can pick that up.
We're not too far from it. We could go visit.
Yeah.
You can go mess them up.
Yeah. Go stomp around. Just stomping.
Here are my gravitational waves.
So the ripple that changed the length of the effective distance between Livingston, Louisiana, and Hanford, Washington, that 1,120 kilometers. I forgot to do the conversion for
We're
you.
America.
That span, that gravitational wave changed the distance by 1/1000th the diameter of a proton, and they were still able to pick it up.
My gosh.
The energy emitted by the gravitational waves in the last few milliseconds of the merger was greater than the combined power of all light radiated by all stars in the observable universe.
I every time I hear about this, I'm like, I can't. My brain just is like, nope. We're just gonna accept it and then just block it out before it melts.
So as you can imagine, 2017, Rainer Weiss, Barry Barish, and Kip Thorne collected their Nobel Prize.
Of course.
So.
Well done, boys.
Yeah, and so this was obviously it's the first direct observation, but it does open up a whole other side of, astronomical observation. We typically use obviously some sort of form of light to observe the universe, stars, exoplanets, those kinds of things. But this allows us to, I'm involved, it allows us collectively to observe the universe in something entirely different, gravitational waves. You just need these big ass detectors to see it. Yep. All right. You ready?
Yeah, I'm ready. Okay.
Yeah, let's do it.
Okay, we're ready.
Number 6. Jade's GS-Z14-0.
Ooh.
I knew this was going to make the list. I just knew it.
I don't know if I know
Did you really?
anything about
No
Jades.
idea. No, I had no idea what Jades is.
Okay, good. I'm not alone. I'm like, I don't know what this is.
It's in Virgo, Liz.
Oh, wow.
Actually, I was like, is it? No, it's in Fornax.
Oh, Fornax. Right. So it's the Southern Hemisphere.
Southern Hemisphere, yeah. All right, so this is from last year.
Oh.
And this is from the James Webb Space Telescope.
Oh, Webby! Webby made the list.
This is the most distant and oldest galaxy currently observed. It has a redshift of 14.32, which means that it appears as it was 300 million years after the Big Bang.
God, that's so soon after the Big Bang.
Yes. Now, we could just leave it there, but there's more to it. There's more to this story. It's over 1,600 light years across, so not big compared to like the Milky Way.
That's small.
It's small. It's small, but still a lot of stars in it, right? So it is extremely luminous, suggesting a high mass, possibly several 100 million times the sun's mass. So, several 100 million stars. Yeah. I mean, it'd be less than that because you have some really, obviously there's really bright stars, so it's less than that.
It's like similar to Milky Way.
Would there be more larger stars, or?
What's that?
Would there be more larger stars, or are these more like?
Well, yeah, because it's very luminous, and so you need the
luminosity of the big
boys.
The big boys shining brightly.
Stars.
Yeah. So, it does show signs of reddening by dust. So there's signs that there was dust in it.
Okay.
So star
stars
formation.
Stars have then exploded to leave that dust and stuff and stardust behind.
Yeah, pretty much. And
then you get more stars.
Not only that, astronomers have detected oxygen in it. So yes, stars have exploded. And it suggests that stars and stuff may have formed more rapidly than previously thought. So the fact that it's 300 million years after the Big Bang, so close to what is called the Dark Ages, where you do not have stars and stuff like that that are formed, it is a major challenge to our understanding to how galaxies form and how they evolve in the early universe. Because it's almost like that should not be there. Why is it there?
Yeah.
It's too soon.
There's not enough material for it to have.
Well, there's material everywhere. It's just that.
Well, oh god, and then what's also interesting is that we're seeing it basically 13.8 billion years old because what's 300 million years, in the scheme of the universe timeframes. So it's like, what is it like today? Is it still around today? Has it merged with something else today?
Exactly.
What has possibly evolved in it?
13 billion years have passed, so you'd assume it would merge and settle into its general shape, whatever it is now. Probably irregular.
Probably. Yeah. Oh, hey! Hello from Qatar.
Hey. Oh, I was like, who's this?
Cheers.
But all right. So think about this for a second.
Yeah.
The time between us and the dinosaurs.
Yeah.
65 million years.
Yeah.
Oh.
The time from the Big Bang to this galaxy is
Jade.
5 times that.
Yeah.
There are like things on here on Earth that are older, at least their species and stuff are older than that gap between the Big Bang and this galaxy. Right. It's incredible.
That's wild.
And it just and I love the stuff where like we don't know. And it challenges us. That's why I want new physics and stuff like that.
Well, and also because where they found this galaxy in this Webb deep field image, right? Or I'm assuming a Webb deep field or a Webb image.
No, this was James Webb.
Yeah, a Webb deep field image.
Yeah, I don't remember. Well, it was the picture that was in.
Yeah, but Webb, has only looked at certain little tiny areas of the sky, so it's like we're looking through like a pinhole basically of the universe and spotting something. So, who knows if this is then like kind of standard for that time frame after the Big Bang. We just don't have long enough time observing.
We need more observations,
and Webb is the first telescope that can peer back that far, really.
And this is one of the things that James Webb is
designed for.
That and other incredible things like sniffing atmospheres of exoplanets.
Yeah, it just goes around. It's like.
Yep, exactly. And so. The question is, are we going to find more objects like this at that time frame? Or are we going to find objects that are even closer to the Big Bang, that are even older? And so, it's gonna be a fun.
Time will tell.
Yeah, it's going to be fun watching what James Webb does. And so, like with Hubble. The Hubble Space Telescope, we knew it was going to give us the most amazing views in the universe. We did not expect some of the stuff it gave us. And so it's interesting to see what Webb's going to do.
Yeah.
And so we'll see.
I like that quote of finding like strange things out there. It's the universe is not only stranger than you imagine, it's stranger than you can imagine.
Yes. There's nothing truer than that, I think.
Are we ready for the bottom 5?
Bottom 5.
Number 5.
Top 5?
Okay, top 5.
Top 5.
Well, in my list, it's
like Casey Kasem's top 10. Anyway,
Number 5, Galileo.
Galileo.
Just Galileo, just discovering Galileo.
Just he was born.
1608, Hans Lippershey invents the spyglass.
Oh, yes.
You said you were going to run out, and then you drop it. 1609, Galileo learns about the spyglass.
Oh, I wonder how.
And improves it.
Did he read it in like a newsletter or?
Yeah.
Well, I mean, he was kind of in the center of commerce area, so news probably came around for the optimism.
I guess it would be a novel new thing.
He was like, "Hey Google."
It would be a novel thing, like, "Hey, you guys check out this spyglass. We can see things real far away
in the future."
So he improves it, and not only does he improve it, he looks up.
He's like, "Hey, I have an idea. Why don't I just like
yoink
point this?"
And the first thing he looks at is the sun and blinds himself, and that's the end of it.
And then we're done.
One of the first things he looked at on the 30th of November, 1609, was the moon.
Hey, moon.
The moon.
Hey, moon. And at the time, they thought the moon was
made of cheese.
Was what? Made of cheese.
Made of cheese.
Yes. Was a smooth sphere.
Oh, what? How? But you could see
because they thought everything in the heavens was perfect.
Oh, right.
Because that's the domain of God, right? And
yes,
so everything in the heavens is good.
Yes, human ego.
And so.
Oh, look, David knows some facts about a telescope. You can tell the photo from Webb because there are 6 lines coming from the stars instead of 4 as from Hubble. Yeah, they're from the reflections of the mirror struts.
So I gotta get all my stuff right.
You gotta get your shit together because he knows some stuff.
All right. Anyway, they thought it was a smooth sphere.
Yeah.
Galileo looks at it.
And he goes,
sees mountains. He sees valleys. He sees craters. And so
he didn't look at it when it was full.
What?
He didn't look at it when it was full.
Well, he's like, I'm gonna look at the sun, so it is a little bit of moonlight doesn't matter.
It's just reflected sunlight. That doesn't hurt vampires for some reason.
Yeah, I know, right? These are the holes, plot holes.
Plot holes of the universe.
January 7th, 1610, Galileo looks at Jupiter.
Jupes.
And discovers little stars next to it.
These little bright lights.
Those little stars became known as moons, and they are Io, Callisto, Ganymede, and Europa. It challenged the common belief that the Earth was the center of the universe, and everything went around the Earth.
Because if other things have stuff rotating around it, or revolving around it, then the Earth isn't alone. The Earth doesn't have to be at the center.
Right, and
Moons over my hammy is my favorite thing from Denny's. I'm sorry,
they're not giving us any money. All right, October 1610, he looks at Venus. He records the phases of Venus. And the only way that Venus could have those phases would be if it goes around the sun. And with that, the Earth moves from the center of the universe to the third planet.
What do you think when Galileo saw that, like, his first thought was like...
It's like, oh, he's thinking, I'm going to gloat over so many people.
I'm going to take the Pope down. But like we've said, what's really cool though is for every like scientist that's doing research, there is that one moment where they are the only ones who know what they know in the entire universe. And at that moment, he knew why the Earth was the third planet from the sun.
was correct.
What?
That Nicky C was correct.
Yeah, and
that's like his Beastie Boys rap name, Nicky C.
And he has the evidence for it. He also looked at the Milky Way, and the Milky Way is made up of countless unresolved stars, so it's not this smooth. They really didn't know what it was, but he looked at it through a telescope.
That's fair. I mean, it just looks like a cloud, really.
Yeah, and
so
there
up there.
Yeah.
All the light from these unresolved stars blend together. All the light from these individual stars blend together, make it look like that cloud going across.
Yeah. Meanwhile, freaking the highest resolution image of the Andromeda Galaxy that Hubble took when it came out. And I remember putting it on the Planetarium dome, and I was like, it looks a little grainy, right? Like, as if it's low res. All those little grains, those are stars. Those are stars. Ah!
Yeah.
They came out with a newer high res a few months ago of that, and I stuck it on the fancy dome I'm in, and I just kind of, here's the stars of galaxies. This is insane.
Oh, God, it's wonderful.
All right, so as Brandon has mentioned, he did look at the sun. And
everybody looks at the sun.
Right, okay, but
not through a telescope.
He didn't know.
We have to say, I think our lawyers, we have a whole team of lawyers say,
don't look directly at the sun.
That we have to say that is a dumb as fuck idea.
Yeah, don't do it.
Don't do it.
Don't ever do it. If you do it, you're dumb.
You're dumb.
I mean, I know sometimes I look at the moon in my telescope, but I just have my hands by the lens, and the moon shows on my hand how bright that is. So I can't imagine the actual sun.
Yeah.
All right. Don't even go out into your backyard, even when an eclipse is happening, and look up at the sun and stare at it like some orange head buffoon that lives on the eastern side of this country. Because
and you know the sun is actively trying to kill you, so just don't even look at it. Just stay away.
Actively trying to blind you.
Pretty,
as well.
It's pretty. It's
anyway,
it's not nice.
It's angry.
Gives us all life though, so I mean.
He did look at it.
Oh.
He
observed, abusive relationship,
he observed the sun when it was low, so its light's going through more atmosphere. So at least he did that.
So he did it for a second, and he was like, "Oh, that was a bad idea," and he probably blinked for like an hour.
I do like it when the sun's really low on the horizon with like a little fog in front of it, and you can actually look at it with no problem and see this beautiful circle.
So his observations fundamentally changed our view of where we are in the universe and the nature of the universe. He published his observations in 1610 in a book called Sidereus Nuncius, The Starry Messenger, which was a sensation at the time and helped establish the telescope as a tool for the scientific exploration.
Make the church roll mad.
Beautiful.
And as you can imagine, yes, the church didn't like it very much.
His excommunication rescinded 1992.
Yes.
Because he really cared at that point.
Number 4.
Oh, wait. I wasn't ready for number 4.
But wait, there's more.
The expanding universe.
Hubs.
1929.
Here we go.
But the story happens. Do we have to take a drink? Well, we gotta take a drink.
I didn't mean to have that on, but because I accidentally did it, then fucking take a drink.
Okay. Every time Liz pushes a button.
Every time. Yeah.
So our story with Hubble starts actually in 1919. Edwin Hubble, fresh out of the army.
Dave said that dude deserved a Nobel.
He
didn't earn a Nobel Prize?
I don't think he did.
Oh, wow.
And actually, I meant to look that up. Anyway, 1919, Edwin Hubble heads west to Mount Wilson Observatory and a 100-inch Hooker telescope.
Hooker telescope.
The largest at the time. So, yeah. So
either way, you're getting something good out of it.
What?
I said either way, you're getting something good out of it.
Yeah. What? Rugby, right? The position is a hooker.
Oh, yeah. Oh. Nobody
Wait,
knows.
There's another position called hooker, too. I just can't remember.
1923,
No,
Hubble
that was
looks
funny.
at Andromeda and discovers Cepheid variables within Andromeda. It allows him to calculate how far away it is and determines it's outside of the Milky Way, which puts an end to the debate of what debate, Brandon?
The great debates. My favorite debates.
Which they were debating whether or not these little clouds of dust and gas...
island universes.
Or island universes, or galaxies like the Milky Way, so really far away, or within our Milky Way, and the Milky Way is the only thing. I believe we might actually have a shot.
We have, I think we have multiple episodes where we talk about this, I'm sure, at some point.
All right, so it expanded the universe, and at the time, they thought the universe was static. In fact,
just all static.
It was not. So galaxies were not moving. No, not moving.
Oh, okay.
Not static. Not that static.
I'm just saying 1% of that.
I was going to say technically.
Is from the Big Bang, so.
Oh, 1% of Winter yelling at Indiana is
yes,
from the Big Bang?
Yes, 1% of is from the Big Bang, yes.
All right. So the universe was thought to be static to the point, and it was so ingrained in the belief at the time that Einstein put his famous cosmological constant in his theory of general theory of relativity, which would, because he quickly realized that the universe would contract because of gravity, so he put it in so that it would stay static.
And that was his greatest...
Well, we'll get there. Oh. We'll get there.
I just want to show I know things.
You do know things. Hubble was not done yet. He did study other galaxies, combining that with other people like Schleicher, Vesto Schleicher, who did a lot of...
Vesto Schleicher. Yeah. This isn't a Star Wars name.
He's a top 10 astronomy name for sure.
He would get basically the redshift of these objects out there. And so combine that with what Hubble was finding, and he found that the universe was expanding. And that is when Einstein calls the cosmological constant his
greatest blunder.
Exactly.
Been there. We all make blunders, you know.
So all this is in the early 1920s, and November 23rd, 1924, because as one does when you make a discovery, Hubble published his findings in the New York Times.
Oh, yes.
And on January 1st of 1925...
Thank you. I got a comment on my shirt.
Oh, okay. He presented his findings to the American Astronomical Society. So this is the first time astronomers hear about this, and he finally gets around to actually publishing it.
Gets around to it.
In a peer-reviewed journal in 1929. That's why the date for the expanding universe is 1929, when it's really the early 1920s.
Great year, 1929. At least something good came out of it, I guess.
Yes, because it all went south in October, right?
Well, at least economically.
Yes.
Not universally.
Number 3.
Oh,
Number
wait.
3, here we go.
You gotta warn me.
The cosmic background radiation.
Yes. I was hoping this would show up.
Yeah, of course it does.
It shows up everywhere. What are they talking about?
Well, it is.
It is in that 1% and that static. That is basically our show in a nutshell.
Static. 1% of that static. I like that. That's Cosmos is Cosmos. 1% of that static.
A new tagline.
1960, Bell Labs in Holmdel, New Jersey, builds a horn-shaped radio antenna.
That's my favorite story. I love this story more than the Great Debate story.
We got episodes about this. I don't know if
we
look
do.
through our channel
We have,
find them.
we do have a shot about it as well.
I think I did the shot on it. Oh, maybe someone did.
It was part of an early transmission system for a system called Echo, which soon became obsolete. And so all this money they spent for that horn-shaped telescope has all been forgotten. However,
technology advances fast.
There are two people who work at Bell Labs.
Ooh.
Hell yeah. Who are they?
Arno Penzias and Robert Wilson.
Arno, Robert.
Yeah.
WP, P&W.
Arnie and Bob.
So, yeah, Arnie and Bob decide they want to use it to measure the intensity of radiation from supernovae scattered throughout the galaxy and universe.
As one.
So that's what they want to do.
As one does.
So they turn it on, the little switch, they turn it on, and they found a uniform noise or that came from all directions in the sky.
Ooh.
And they were like,
aliens.
What the fuck is this?
Aliens.
Yeah, pretty much.
Okay.
They cleaned the equipment. They evicted.
Oh, I'm sorry. Can you tell the people what was in the equipment they had to clean?
White dielectric material.
Okay.
Guys.
All right. Okay. It's just the best
Who's telling the
part.
story, Liz? Not us.
All right.
Not
I'm
us.
just here for the ride.
I want to do it too.
They evicted a family of pigeons that had moved in.
Oh, that's so cool.
And the cage they used to capture the pigeons, I saw at the Smithsonian.
Really?
Yeah, it's the coolest thing.
They even swept out what?
Pigeon
white
shit.
dielectric material.
Yes,
Pigeon
white dielectric material, also
Pigeon
known as
Pigeon shit.
Bird shit.
Bird
Pigeon
shit. And so
that's a new tagline. Cosmos of Cosmos. Pigeon shit.
All right. So once that had all been completed, they turn it on. Static still there. They're like, what is going on?
They just got a broken microphone like we had last episode.
Yeah. So they didn't have to rule out other stuff. They ruled out urban interference by pointing it at New York City because it's right across the bay from New York.
Yeah.
And then they pointed it away. Same static.
Thing. Same.
They
Did they check all the cables? Did they turn it off, turn it back on again?
Yes, they did that.
Yep.
They checked out. They ruled out radiation from the galaxy or extraterrestrial radio sources.
Aliens.
What could be any solar system objects.
All right.
They even ruled out an above-ground nuclear test that occurred in 1962.
Wild.
Yeah. So they at that point. They concluded it was not the machine, it was not random noise causing the radiation. So they were completely...
Ghosts.
Flummoxed.
Yes, they were flummoxed, exactly. All right. While all this was going on, Robert Dickey was less than 30 miles away.
Top 10 astronomy name.
Fucking what a...
Bob Dickey.
And...
I won't go for the lowest hanging fruit.
And oh man. Robert Dickey was leading a team that I
find it in your notes. Scroll.
Right, he led a team at Princeton and had predicted that the Big Bang would result in a microwave background radiation, so the afterglow. And so he built a radiometer to detect that radiation. And in 1965, Penzias has happened to mention the signal that he observed with Wilson to a colleague who had read a paper by a member of Dickey's team.
Wow, so it's like it's just like a luck of oh hey, I was reading something. Oh, now they mention it. Meanwhile, he's just complaining. God, we keep getting this static,
and it gets better.
Penzias then decides, I'm gonna call Dick up and see what's going on.
Dick.
So he phones Dick, and Dickie took the call, and he took it while having lunch with his colleagues.
Oh.
Yeah.
Wait, hold on. So he's out to lunch, and so the restaurant, I'm assuming, brings the phone and you have a call, sir, because they don't.
Office in Princeton.
Oh, okay. I was like, because you don't have cell phones, so it's like they're just eating lunch in the office.
Lunch.
Okay, I just picture they're out to lunch because it's the '60s. They're drinking, they're smoking, they're out to lunch. I've watched Mad Men.
Yeah.
And after he has that conversation, he hangs up,
And he goes
He
home.
says.
He slowly turns to his team, and he goes, "Well, boys, we've been scooped." The whole slowly turning was me.
Okay, so dramatic.
Yeah, and
Make it dramatic. I mean,
in the paper that Penzias' buddy read, it actually said a great place to look for this background radiation would be the Bell Labs antenna.
Oh.
So they actually said this antenna would be a great place to find it. They just word didn't get to the antenna.
And just for all those Google this antenna, but it also looks like those old timey.
It does.
Like horns.
Yeah.
Be like, what did you say, sir?
The cornucopia thing.
Yeah, the cornucopia horn.
So, talk about getting a Nobel Prize for stumbling into something. 1978, Arno Penzias and Robert Wilson get the Nobel Prize in physics.
Right. And they didn't fully grasp what they had discovered or even what the Nobel Prize was really for until they were reading about the Nobel Prize in the New York Times. And the New York Times writer succinctly summarized what they had found. And they go, oh, that's what we did?
Oh, shit. Well, because this isn't their, expertise area. This isn't what they were even intending to study. So it's
Yeah,
they just were, happened upon someone else's research, basically.
Okay, are you ready?
Wait, okay.
Number 2, dark matter.
Ooh, I love this picture, first of all, that's happening.
I was like, I gotta use that picture of his wiki.
That's Wiki?
That's
I don't know if
Fritz
I've ever
Wiki.
looked up what he looked like before.
Yeah, it's Fritz Wiki.
Oh, God.
And Vera Rubin. Top left, Vera Rubin.
Oh, there we go.
You know what? These could be good Halloween costumes.
And
Fritz Wiki.
and bottom right, Fritz Wiki.
Oh, no! Oh, no! Oh, no! Oh,
What'd
God!
you do?
I'm messing up all the buttons! All right. Okay,
So this is where we
Okay.
So, David, that answers one of the questions you had. Yeah, we're drunk at this point.
We're professionals.
All right.
Drunk professionals.
Okay, so
It's okay, Leia.
dark matter.
Our dog Leia is concerned because I started yelling.
The story of dark matter, the journey into what is dark matter, begins
Tale as
in
old as time.
1933 with Fritz Zwicky.
Zwicky.
I could do a whole show on Fritz Wiki. In fact, I might do that. My next show.
Have we
I
not
think
done
we've
that
already
already?
done that.
We have not. I looked it
No?
up.
Oh.
I looked it
well,
up.
our Xbox name is the Zwickster.
Yeah, we did. We did a shot. We did a shot on it.
Okay.
But we did not do a full-on
full
show.
episode on Zwicky. I thought we did because
No, because he's got all kinds of crazy stuff.
Yeah.
And then we can challenge each other to push-up competitions, just like
We
Zwicki
could.
did.
Yep. I mean, we have talked about him enough in all of our shows to where we can say, well, that's
I
the
guess
show.
so, yeah.
But
Wait,
anyway,
montage clip.
so I might, my next one that I might write might be Mr.
Unless I get through
Zwicky.
it first. Kidding. I want to steal it from you.
Anyway, he was
Work
looking at the
together.
Coma cluster, this cluster of galaxies. The average speed of galaxies in a cluster is dependent upon the total mass of the cluster. Lower mass, galaxies don't need to move as fast. Higher mass, they got to move faster to stay within it.
Okay.
So what he did was he found the speed of the galaxies, the average speed of the galaxies, and from that he was able to get the mass of the galaxy, of the cluster.
The way these people's brains work.
Right. But you got to do something else.
Okay. Now,
Oh.
Susanna gets your Zwicky thing.
Okay.
Oh.
Yeah, Fritz Zwicky is one of my most favorite astronomers ever.
Not personality-wise, probably.
Huh?
I said not personality-wise, probably. But
Well,
Complicated guy.
he's
Also, did some really good things too.
that's true.
um.
That's just humans.
So then what he did was he then added up all the light that he would see. And basically
Add up the light.
you add up the light
Add up the light.
and that should tell you basically what the mass is related to stars. And at the time it should be very similar to the mass of the galaxy. At
Makes
the
sense.
time.
Sure.
But what he found was that if you add up the mass of the galaxy based on speed, and then the mass of the galaxy based on the stars you see, that the galaxy cluster is actually 10 times the mass of the stars you see.
So it's got more mass than it should.
It's got more mass than
It's got
it
some hidden
should.
weight. Well, mass is not weight. I will clarify that.
And he called it dark matter.
Yeah, because
he was the first because he couldn't see it, and all of that.
I guess, what are some other fun names for dark matter? Unknown matter? No.
Oh, that's a good question.
Dark matter, unseen
make-believe matter, imaginary matter.
Yeah.
All right, so basically, he also, based on general theory of relativity...
Mysterious matter.
He predicted the existence of gravitational lensing by massive galaxy clusters. Mm-hmm. And so it bends the light, and you'll see these arcs and stuff like that. He was ignored by astronomers.
More cushion for the pushing, Elizabeth, am I right?
He was ignored. He was ignored by astronomers.
Uh-huh.
And
okay, so they're like, you're crazy.
Yeah, pretty much. Okay. Because he did have some crazy things. But he also was the first to, talk about neutron stars and things like that. So yeah, he had a lot of great ideas. He was it was so ignored that the first gravitational lensing was discovered in 1979, 5 years after he died. Mm-hmm. So no wonder he thought astronomical journals were bulging with useless trash, quote unquote.
Wow.
Uh-oh.
And astronomers are spherical bastards. No matter how you look at them, they are just bastards.
Spherical bastards.
Spherical bastards.
Spherical
Cheers,
bastards.
Everybody.
Yes. I forgot about the spherical bastards term.
Why do we have to?
Oh, because I said more cushion for the pushing, right?
Oh, okay.
And then
all right.
brother's on here. I was just in general.
All right, 1970. I got a whole nother one I got to do.
Very nice.
All right, Leia, go again.
I don't get it.
1970. Vera Rubin.
Vera! That's a fun name.
Robbed of a Nobel Prize.
Yeah, well, because, vaginas.
She was studying the motion of stars in the Milky Way. Mm-hmm. And at the time, the thought was move fast. A very solar system model. So near the stars in the center of the galaxy should move faster. And then the ones way out.
We got one model.
So they should slow down as they go based on Newton's theories, but also general theory of relativity also reduces to Newton's theory in the end. So that was the general thought at the time. But what Vera Rubin found was that stars in the distant part of the galaxy were moving pretty much just as fast as the ones in the center of the galaxy.
Ooh, so they should. It's like, wait a minute, you shouldn't be going so fast.
And she did some calculations and found that there was some sort of hidden mass 10 times the mass of the visible matter.
There you go. Huh. That's weird.
It ain't no matter.
And so, both Zwicky and Rubin said that sure, this is in the galaxy, but it's also these cluster and also in the Milky Way, but it's throughout the entire universe as well. And so Vera Rubin said, quote, in a spiral galaxy, the ratio of dark to light matter is about a factor of 10. That's probably a good number for the ratio of our ignorance to knowledge. We're out of kindergarten, but only in about third grade.
Yeah.
We're not sure. Again, we're not sure what it is. It could be.
That's great in Oklahoma.
Dark matter. Dark matter could be things called WIMPs or machos. It could be a combination of two. It could be something else.
It could be anything. It could be aliens. We don't know. We don't know.
Really,
we just don't know yet.
Really dense aliens.
But yes, Vera Rubin Observatory.
Yes,
opening
Vera
soon.
Rubin.
It better be opening, guys.
Vera Rubin robbed of a Nobel Prize.
Well, yes, because again,
quite a few robbed of Nobel Prizes. Anyway, ready?
I think we know.
Oh,
Number one.
Hold on.
I think we know. I think we know. I think we know.
Drum roll.
Number one. Dark energy.
Dark
energy.
Is that what you knew?
Yeah.
All right. So, dark energy is 1998. Hubble Space Telescope, and basically to borrow. I can't remember the particle physicist who said it, but who ordered that? Nobody was expecting dark energy.
Yeah. Oh, hey, but David did have a question. Given that he from the previous one, CwC discovered neutron stars.
He didn't discover he predicted them.
Did that impact his theory on the lost matter?
That impact his theory? I mean, it could. So neutron stars would be considered like machos in this whole wimps versus machos thing. But well, they would be related to machos. I mean, there's a lot of maybe I don't know that it didn't. There isn't anything that I've read that said
we don't know
that
we don't.
His
it's okay.
thoughts,
we don't know.
Yeah, I mean, scientists can say that. Wait a minute,
what? Okay, sorry, we're getting distracted by comments.
Anyway, so I mean, it could.
Nights for the next 10 years,
It could affect his thoughts on dark matter, but I mean, all he could say is it's something dark.
There's something.
He didn't elaborate on
there's some matter we can't account for,
things like that. Yes. He just said this is whatever it is, 10 times.
And then you have magic energy to go along with the matter. I feel like matter and energy are like, kind of intertwined through the universe.
Matter's frozen energy. Anyway, dark energy.
So you just broke Liz there?
Anyway. Oh my God. All right. Dark energy. Got focus.
Potential energy.
Okay.
Liz.
All right.
So, a brief history. 1912, Henrietta Swan Leavitt discovers Cepheid variables. In 1910s, Vesto Slifer uses a spectrograph to measure how fast nebulae are moving away from us. 1922,
Ooh.
Alexander Friedman, Russian.
Russian?
He's a Russian.
Okay, he said Rushman.
I heard Rushman.
Yeah, Rushman.
Uses general theory of relativity to give multiple possibilities for the evolution of the universe. Expanding was one of them. 1927, Georges Lemaitre, Belgian.
You only drink when the dog barks, but you can drink for seeing the dog.
Yeah,
oh, he's barked a few times. You guys haven't caught it.
No, we just don't hear it. Your noise suppression is well.
He also determined the evolution possibilities for the universe, and supposedly...
Elizabeth is making us drink, as Elizabeths do.
Supposedly, George Lemaitre did not know about Friedman's findings.
Supposedly. All those people are reading each other's shit all the time.
Well, the Russian Revolution had just happened.
Oh.
5 years earlier for Friedman,
right.
So
maybe not.
It probably was not getting out of the Soviet Union.
That's fair.
But he was a priest. So, Catholic priest, interestingly enough.
Oh, those are the most
basically coming up with the start of the Big Bang Theory. 1929, Hubble says the universe is expanding, and at that point, the question was: is the universe expanding, or will it continue to expand? Is it slowing down?
What's going to happen?
Or is it going to continue to?
Is it going to be a big Crunch Wrap Supreme?
Yes. Yep. Or is it going to continue to expand at a constant speed?
Like what happens after a Crunch Wrap Supreme?
1998, 2 teams study supernovae.
Wait, teens?
Teams.
Oh, okay, teams.
With the Hubble Space Telescope, they were studying Type 1a supernovae. So these are white dwarf booms.
White dwarf booms. Dwarf booms.
And these have a certain brightness and are considered standard candles. So you can use them to figure out how far away something is.
Yeah.
At a certain redshift, though, they noticed that supernovae were dimmer than expected.
Oh.
So at a certain point in the universe's history, these supernovae are dimmer. So after removing the effects of dust in the universe, because you got to do that, because that can dim stuff.
It's dusty out there.
Maybe they just weren't motivated enough. They just were lacking conviction.
I like that. Unmotivated supernovae. They determined that the supernovae and the galaxies they live in were further away than expected.
Ooh. Ooh.
So that means that instead of slowing down, the universe expansion increased and made the supernovae further than they should be.
Hey, you know what we need to do on this show is we need to do the balloon visualization where you put with the dots on the balloon and then you blow up the balloon and you see how they all, you know, that would be a good visual.
And we'll just explain it for the podcast listeners too.
Yeah. Well, they can just watch the video, people. Actually, the videos are now on Spotify, so actually they can watch it on Spotify.
Oh, that's cool.
Yeah, because you watch Spotify and there's
I do watch Spotify,
playing. Yeah.
I don't know you watch Spotify.
Well, I don't.
Yeah, you can watch that. Well, you listen. I listen to it, there is video. There is video that can.
Of course, I also. Yeah, never mind.
So what could it be? It could be a thing called vacuum energy, quintessence, space wrinkles, which are cosmic strings.
Space
Botox.
Space wrinkles.
Space wrinkles necessitates the existence of space Botox. Smooth out those gravitational waves, people.
So easy trick. They're basically one-dimensional cosmic strings that are wreaking havoc. So space wrinkles.
Has wrinkles too. They wreak havoc on youth.
Could be a flaw in general theory of relativity. In fact, Einstein was the first
to admit... There's no flaws that we have found in general relativity.
Pretty much, yeah. In 1919, Einstein floated the idea that there might be a modification to general theory of relativity, but didn't go anywhere. But people are still trying to
modify it.
Trying to modify it, but it just seems to work in every other instance.
General relativity. It just works.
It just works. It's perfect.
All right. I do have some honorable mentions.
Honorable mentions.
Won't get into them.
We don't have a graphic for this. That would be cool. I don't. Hold on. We got a comment. I understand because we're on a delay a little bit. I understand dark energy fits the observations best, but may I ask what kind of exotic alternative possibilities there might be to explain the phenomenon? You are too well spoken for this podcast, David. Let me tell you.
Quintessence. Well, I can't quite remember what quintessence is.
It's an essence of 5. It's
nice.
A party of 5.
Quintessence is there's like an energy in the universe. It's not the vacuum energy.
Yeah,
it's like the force.
Energy. The force.
Yeah, I guess. So, I mean, it's like a negative energy that causes the universe to expand, which is different from the vacuum energy, which is a very quantum mechanical kind of thing. And so.
Basically, nobody knows.
And there was also the idea that maybe the standard candles were just wrong.
Oh, yeah.
Yeah, but you know, the thing is like you do look at standard candles, and they're pretty standard.
But occasionally, when you buy a candle and it just doesn't, it's like you got a bum candle or one that doesn't really stay.
I do like, I mean, the fact
what do we take a drink for? Was there a dog sighting? Those aren't the rules, but you're making up your own rules.
He's getting antsy, that's for sure.
A Star Wars reference. What was the Star Wars reference?
Oh.
The Force.
Oh, the Force, of course. God.
All right. Honorable mentions.
Okay.
How stars shine.
How does the sun shine?
That's a good one.
The sun is the mass of the super
Eddington, Cecilia Payne, Gapachin, Hans Bethe. So we had some astronomers that were definitely involved with that.
Okay, so they figured out. So it was figured out how stars shine
through
nuclear fusion.
Eddington proposed that stars use nuclear fusion. Cecilia Payne Gapachin determined the composition of stars is primarily hydrogen and helium. Hans Bethe in 1938 precisely determined the reactions the sun uses. There's 2 of them.
That's going on.
Proton chain and the CNO cycle. Pulsars also on the list.
Oh, pulsars. Okay.
Yes, Jocelyn Bell Burnell.
There's an episode or a shot. There's a shot on.
Yep, exactly. In the 1960s, found pulsars left out of the 1974 Nobel Prize.
Because
quote, first, demarcation disputes between supervisor and students are always difficult, probably impossible to resolve. Secondly, it is the supervisor who has the final responsibility for the success or failure of the project. We hear of cases where a supervisor blames his students for a failure, but we know that is largely the fault of the supervisor, which I love that. It seems only fair to me that she used that word, he should benefit from the success too. Thirdly, I believe it would demean Nobel Prizes if they were to award to research students, except in very exceptional cases, and I do not believe this is one of them. Finally, I am not myself upset about it. After all, I am in good company.
She says because she has to due to the
she was very diplomatic
and wanted to keep her probably position and whatnot.
Another one. This is not a number.
There's so much.
I'm so used to it.
Number honorable mention.
Next bullet point. Tycho, Kepler, and Newton. I don't think you can.
I mean,
not talk about those.
Copycats.
Sure.
Percy and the rovers. All the rovers on Mars. They've made some amazing discoveries. The Voyagers, with the grand tour of the solar system. New Horizons with Pluto and whatever that second one it went to.
Yeah.
But really took New Horizons really took Pluto and made it a real world.
Oh my God, it's gorgeous.
You're a real world.
You're a real world. No, you're still not planet Pluto.
Not just 6 pixels, but hey.
Osiris Rex.
Oh, yeah. Oh, Osiris.
Aristophanes, which
nice callback.
Measured the
circumference of the Earth.
Yeah, the circumference of the Earth.
Okay, yes, using
two
a
sticks,
well,
using 2 fucking sticks.
Yeah, I mean,
Yep.
The Greeks did some shit.
Neutrinos.
Oh.
Yeah, there's a whole problem with the sun.
Neutrinos always just pass me by.
Oh my God.
And through you.
I like that the neutrino collectors are basically these underground pools of water, and there's that one in where's that one in Japan that has like
but
those
also
balls that are like.
But
it just looks crazy.
Also, when you take your clothes, dry cleaning fluid.
What?
Some of them also have dry cleaning fluid in them.
Why?
I don't know. It gets the connection. I mean, it gets the.
Squirt some Tide in there and.
No, dry cleaning fluid. So the neutrino hits something in it, it flashes.
Oh, okay.
So, fast radio bursts, FRBs.
FRBs.
Quasars.
Oh, quasi-stellar.
Now we're just naming neat shit.
Things. Quasi-stellar things.
May I propose a topic for the Hangover?
Yes.
Not saying we're going to right now, but I think this would be fun.
We're about to go do it.
We can do, not say the top 10, but our favorite theories that were close to being right, or our favorite theories that were horribly wrong, but people put out there in the first place.
And finally, proplyds. That was last item.
Proplyds!
Little
cocoons of forming planets and stars.
Ooh. And that is my top 10 and honorable mentions. As you can see, the honorable mentions were just as long as the top 10. And Cold Fusion, that's a good one. And what are we doing in 2 weeks? Are we doing
We're doing a High in the Sky.
High in the Sky. What's next month?
For June. We're heading into June, so we'll be doing a High in the Sky for June. Elizabeth says, Jude, what is you use the glowworm caves to measure neutrinos? Mike is trying to listen. What if you use the glowworm caves to measure neutrinos? Look, I'm down to go to New Zealand. We're going to the UK in a few months, but I'm down to go to New Zealand.
Yeah.
We're down for a fellowship trip to New Zealand in a couple of years.
That would be great to get to New Zealand and do an episode of New Zealand.
We just Weege.
So that is my top 10. I worked on it for a couple weeks.
It wasn't a last minute thing. You put some effort into it.
I did work on it a lot yesterday, but I went back and forth on a lot of things.
If you could include theories, how much did that change everything? Well, what theory would have been the top?
The theories
are
Jesus
all Christ, it would have been
because in my mind when I was thinking about this, I had gravity number 1. Like that was the foundational arc, really.
Yeah, I mean, as you saw, we did talk about general theory of relativity, but quantum probably be number 1.
Well, because you're a quantum boy, you're a fancy physics man.
I do.
See, and I'm a big boy. I like gravity.
That's weak.
My force is stronger.
Well, thank you guys for joining us on our Mike's Top 10 Astronomical Discoveries,
In
which
4
I think
weeks,
we can
I'm doing CwC.
agree with. We did not do gravitational lensing. That was not one of the top 10.
We just touched on it with CwC.
But I mean, really, I would say all astronomical discoveries are the best, so it's hard to actually rank them. But I go along with your top 10. I pretty much agree.
Yes, Susanna.
We will have a special guest star
in the fall
in the future episode of one of Mike's progeny. I did not say that word correctly.
You will sit right here in the middle. Also finish your drink.
Between us, so prepare yourself for that. Anyway, thanks for joining us.
Suzanne and I are both very dramatic.
They are so dramatic. Oh, God. Mike gets it from Susanna, really, but no, Susanna, you get it from him 100%. Anyway, thanks for joining us, everyone, on this episode of the Cosmos. You can check out The Hangover after this, but for now, we'll see you next time in a couple weeks. We'll have High in the Sky for June. Also, if you want to participate in our new Cosmos with Cosmos book club, we are currently we are going to be reading Chasing the Sun by
David.
Chasing the Sun by an author, Cohen. Yeah. Something like that, which we will then review in our August hangover of High in the Sky. Yeah, he does get it from Susanna. There you go. But for now, thanks for joining us, and we will see you next time. Bye,
Cheers.
Everybody.
Bye.
Resist.
If you're with us live now, we will be right back after a short break with The Hangover. So we will see you soon. Sit tight, grab a drink, go to the bathroom, get another drink, whatever you want to do. Enjoy.
Hey.
We are back.
Welcome.
We're back for the Hangover with Cosmos, joined by special guest Wintercat, who's apparently snuggling down and joining.
I think Winter is snuggling to just take a break from Indiana.
Probably to get away from Indiana. No, because he loves us.
All right.
You look at him. He's like, yes, please. Okay. Anyway, I believe our main episode for this hangover. Yeah, you're tangled in my headphone cord, Winter. It's fine. Was the top 10 astronomy discoveries according to Mike. So very subjective, but I would agree with most of what you said.
Yeah, I want to know what you guys would add to it.
I thought you were just asking, like...
Yeah, what did I leave off that you would rather have in there?
Well, I wasn't ready for having only observational only, for example. The criteria, I wasn't ready for that.
Well, I had to do that.
Right, that makes sense.
You know what? No, okay, but we're in a hangover, so you can add theory, you can add whatever. Open it up. And if you do add a theory, I'll tell you if that was going to be on the list.
Right now, I'm still figuring out. Okay, if it's more fundamental, does it matter more? Like, for example, is Galileo and Copernicus, are they actually ahead of a dark matter because it is foundational to everything else? For example, but they all still belong in the top 10 for sure. So I was just gallivanting ideas there. Let me think about
Copernicus and who?
Galileo.
Oh yeah, Galileo.
The two main ones, you know.
I mean, he made it, but it was on observation.
You guys think about it, and I'm just reading Jack's comment that he has an end of year staff party tomorrow. And he's making Midwestern salads, so basically a ton of Jello, instant pudding, canned fruit, and whipped topping, which I am all for.
Who are the people that make? The people that make pudding and Jello were like, we're going to invade the Midwest and we're going to say this is a salad.
They got him.
They got you.
Ron, to your question, says phase of the moon. Kepler went pretty hard with the orbit. Yeah, just the laws of motion.
And I did consider putting Kepler in there because Kepler did work with the observations from Tycho. Mm-hmm. So I did think about that for a moment.
Tycho had a pet moose.
Yeah, I was so similar to what David just put about Water on Mars. I was thinking about realizing that Venus and Mars are not capable of life currently. Like, for a long time, we thought Venus was a tropical world, and we had the canales on Mars, and understanding that they do not have the correct atmosphere, they do not have the correct environments. That in itself is a major discovery. So I might put that up there.
Ask me the question, Brandon, about Venus. Ask me the question.
How long does it take to cook a large pizza on Venus?
Brandon, it takes 9 seconds to cook a large pizza on Venus. So I don't recommend it.
Tycho could party with the best of them.
Tycho,
to the point where his like the what is it the myth?
To go pee.
The myth
that he held not going to the bathroom, and so he died.
Exploded.
Yeah, that's how he died. Yeah, the moose died falling down the stairs. Do you listen to the dollop, David? Because I feel like you only know that information if you've listened to the dollop episode on.
Maybe you just like reading about Tycho.
Okay, well, yeah. I guess you could like reading.
I mean, that is
what most people do, read.
That is pretty hardcore, though. Moose gets drunk, falls down the steps.
Poor moose. Like, it didn't ask for this life. It doesn't know what is happening to it.
But it probably died happy. It's probably pretty quick.
Okay, all right.
Oh, yeah, you should check out the Dollop.
The Dollop podcast.
All right.
Anyway.
So, favorite theory that was an almost theory. Almost.
So, I will lead off that I am going to make a whole episode about this. I've decided because we can do that, and I think that'll be a lot of fun. I'll top 10 fire it as well. But for right now, as we're just kind of spitting ideas out, What?
I got distracted by dog names. Tried to name his dog Tycho, but settled on
Yeah.
Ziggy Stardust.
That's a good one.
That's a good one. Tycho was on my list, but I went with Mr. Baggins.
All right. Well,
It
my
had to be
favorite
It had to
theory
be Frodo.
that did not make it anywhere because it's dumb was I had given, it was an adults night out lecture at Arizona Science Center.
No, you can't. The place that shall not be named.
I gave an adults night out lecture at the place that shall not be named. Leia, lie down. You don't need part of this.
Please, let me see the label. And what happened there, Mike?
So the topic was what methods astronomers use to find exoplanets. And basically I just ran down the different ones at the time. Yeah. This was before the Kepler deluge of data.
Pretty cappy caps.
And this guy comes up to me afterwards.
Not the meteorite guy.
It's the meteorite guy.
See some space rocks.
Space rocks. Space rocks guy.
In my pockets.
Yeah. And he proceeds to tell me how he has a theory of the universe that is correct and explains everything. And how he even gave some bizarre fucking example. And he was like, basically it was in mathematics you have things called geometric series. So basically it's a series of numbers. It was based on a series, mathematical series, and he said I used it to explain something that happened with a star, and I was like, dude, it's not right. It's not right. No, it doesn't explain everything. You can't. Sure, you might be able to take a series and calculate something with it, but it doesn't fundamentally explain anything with the universe.
And he was like, "I've solved it."
Yeah, I've solved it. I got it all figured out. I got it all figured out. Einstein was wrong. I mean, he basically was saying Einstein was wrong. That
he's been wrong, proven physics, correct so many times.
Jack, I don't know what you're doing, but stop.
We're playing.
Dog Jack.
Jack.
Podcast Jack. Stop doing what you're doing.
Midwestern pudding. Salad.
Yeah, and at the time I was just like, dude, I mean I told him he was wrong. I'm like, it's not right. You don't you're not taking into consideration.
Everybody has their theories. Hypotheses.
Yeah, it was just my god.
Everybody wants to know something.
But the thing was, I was trapped, and I could not escape it.
Yeah. We've had those.
So I mean, there at the end of the.
You just gotta smile and nod.
Yeah. So at the end of the at the end of
they were Canadian
the talks, like you do have a lot of people come up and ask you questions, and
of course.
he was just I think I had to get somebody to ask him to leave because he was taking up everybody else's time.
Right, and
I hate when it happens.
Oh my gosh.
So it was. Luckily, it was in the IMAX, so I was on the stage. So at least he was not like right on me, but I also could not get off the stage.
Right.
So.
Oh my gosh.
Let's see. I think one of my favorite inaccurate theories is the cause for the seas on the moon.
Oh, okay.
Uh-huh. And this theory is actually put out in the 1920s, I think it was. And of course, the seas on the moon, I'm sure this may pop up in the top 10 maybe. Like it was volcanic flows from eons and eons and eons ago. But this scientist put forth that they were actually migrating insects on the moon that caused the seas. So that's why it appeared darker than anywhere else.
I've not heard this before.
Okay.
Yeah.
But they don't move.
Insects?
They don't move. So how are they migrating?
Yeah, you would see that migration pattern. You would see,
because this was 1920s,
change?
so photography's only around for 50 years,
Okay,
we can
fair.
say. And so by looking at the
way.
drawings of Galileo, looking at the drawings of all these other astronomers, we can see the slight differences between them all, which, by hand there'd be slight differences, sure. And maybe he was thinking, well, that's clearly migrating insects on the moon.
Obviously. What else could it be? Nothing else could explain it, but
could be crabs.
Insects
They could be migrating
crabs. Is this like a prequel to like Super Troopers? Or not Super Troopers,
that moon thing?
What troopers? What troopers with the insects?
Yeah.
Starship Troopers. Starship Troopers.
Yeah.
Starship Troopers.
Thank you.
It's just the prequel to Starship Troopers.
Yes, it is. Yes.
That's where they store before they invade. Thank you. Yes.
Oh my God. Well, 1920.
It's either that or it's Nazis.
Yeah, that's plenty
Nazis on the moon.
Well, they went there.
I mean, in the 20s and 30s, and even through the moon landings, even through there were wild theories on the planets of the solar system. I think we touched on the tropical Venus, for example, the life forms that could live on Mars. It was just a wild time. We know enough to think we know things, but we're still pretty fucking stupid. Like, we were still in kindergarten.
Yeah. What and my favorite phrase, of course, from the exoplanet show, Planetarium show.
Say it.
I'm gonna say the line. What's the show? I can't remember the name of the show.
It's called Exoplanets, isn't it?
No.
Extreme Planets? No.
Extreme Planets. We're in the horse and buggy days of space exploration.
Yeah, isn't Ron part of that? Was it Clark?
Was that a Clark Planetarium production?
It was.
Extreme Planets?
Yeah.
I don't know which one. I can't tell between. It was either Clark
I just know that and Cosmic Dragons.
Yeah, that's the best line of any
Planetarium
show out there.
Also a Clark production.
Oh, that's my favorite.
We're big fans.
My favorite Planetarium show is that one.
Wait a minute, Black Holes?
Black Holes.
Oh, yeah.
The Black Holes by Clark. With John Delancey as narrator.
I do like me some Black Holes.
And yeah, I know. You're the Quantum Man.
Well, this is very. Oh, maybe that can be like my Halloween costume.
A Quantum Man.
Where
you just don't show up because you're so small.
Where. Oh yeah, there's that. Or because like you can't.
Yes, he has his own planetarium that must not be named. Sorry, Ron,
because of like the Heisenberg certainty principle, you can't know the momentum and the position, so I'll just be blurry. My costume would just
that
be
would
blurry.
be cool if you like had like a screen
you just
that you attach to yourself, and it's like a blurry picture of you in motion that you just walk around with like attached onto you. That's actually kind of fun.
And then people will be like...
You can give a little science to the kiddos of where we live.
Yeah, and people in Oak Ridge will be like... even after I do the science, be like, what?
I mean... That's most science that I think about. I'm like...
Yeah. And I'll be like, hey, you know what? Even most physicists are like, what? When it comes to quantum. So, you're in good company.
I mean, it's hard... to comprehend.
It's it wasn't like somebody like Feynman or somebody said that like it's just drunk paraphrasing is like you can't really comprehend quantum physics, and people who think they do, they're just...
There was some article that I saw recently was like they did like the first photograph of image of free electron, neutron, protons, free protons, something.
I only care if the scientist went, look at this photograph.
And I read the article and I watched and I looked at like these images and I was like, they're just round things that are like in red, and it's like so hard to comprehend like the size scale reading the article, where it's like so many sizes below the width of a human hair, and I'm just like,
you know how we do a major photon update once in a while?
Yes.
We should do something similar where we have something at our level
then
decreasing in size by a certain magnitude per second or per minute, and just follow it for like a year.
That would be kind of interesting because we don't really know how that goes, right?
We had to find the right amount, the right scale.
The math. We gotta do the math, right?
All right, hold
but
on.
It sounds like a fun math project for someone who loves math.
We'll give it to that guy who did the series.
Yeah.
All right, hold on. You got to say that again because I was looking.
I know. I was looking
at
David's
chat. So say I will not look at chat now.
Oh, you weren't paying attention.
I was not paying attention.
What that meant? You didn't even.
That's why it needs to be reset.
We need to do, instead of going major photon going out, do one that goes in, that goes down to the really small,
deeper and deeper.
Like
powers of 10.
Yeah.
Yeah, a microcosm thing.
Okay. Yeah, we could do that.
That'd be
fun. That'd be fun. Anyway, just to highlight what we were distracted by in chat, or what Mike was mainly distracted by in chat, was there's a new show, Messengers of Time and Space, dropping this week that's free for planetariums out there that Ron worked on. And I know Ron's work, so this is going to be good shit. And then Dave said, just dressed up strangely, and then when someone is starting to ask what you are, scream, a tachyon.
Wait, but it's a tachyon! And then run backwards.
Trio tachyons.
That would actually be kind of funny.
And then they'd be like, "Why are you running backwards? Because tachyons go backwards in time."
That'd be fun. That would be fun. See, and also educational. I like it. And yes, free is the best F word. But fuck comes in a close second.
Meanwhile, because it's so versatile, fuck. But anyway,
yeah, I just said.
Meanwhile, I'm reading Ron's thing, and I go, "There's gonna be more tickets I gotta deal with." Because people are
this is just for us.
"Hey, I got this show."
The I get it.
Yeah, I got this show for this free show, and how do I make it work on my dome? I'm like, oh.
Oh, I know who's going to ask that question.
And now you can just be like, thanks, Ron.
Yeah.
Every time, thanks, Ron.
I know who to blame on that.
Thanks, Ron.
So I do try to say cheers, Mike, in all my ticket responses.
Which I've also taken up as my salutatory email message.
I do try to be nice, though you can tell when I'm annoyed when it says thanks, Mike.
No. I use thank you when it's like a more professional kind of thing.
But for any tickets that I get for this show that Ron did, it's gonna be P.S. Thanks, Ron. This ticket brought to you by Ron Proctor.
Then we start spray painting it all over town in little spots. So you gotta find the thanks, Ron.
Thanks, Ron.
Around the world.
Oh, that'd be great. And then you could say, if you find thanks, Ron,
we're gonna go. Okay,
and take a picture of it. You get a free planetarium show.
We'll go write it somewhere in Doug this year at the Digital Users Group Conference. We'll go write thanks, Ron, somewhere.
Oh, but you know what though? It's when I produce shows, I at the place that will not be named, I would put Easter eggs in it. Thanks, Treehouse Adventures has Easter eggs in it.
Yeah.
And so we could do that. Hashtag thanks, Ron.
Anyway.
I
don't know if I have a theory that's wrong because I don't know all the theory stuff that I don't pay attention to that shit. I just can kind of basically
steady state.
Evolution.
Steady state.
But the one that I did think of with my pedantic mind, is that the word that I want? I don't know, but it sounds like it's smart. Is the flat Earth theory not correct? And will never be correct. We have photographic observation, so I just want to say.
All right. So.
Well, also, no. I wanted to actually take it back. People thinking that, it's really kind of the.
Cats.
There's two. Indiana joined us for the first time.
Oh.
Meow, 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 meow.
And he's hunting.
He's hunting Winter, so Winter is living his nightmare right now.
If Winter had not gotten hey, we might be able to hear static.
The 1% of the universe. But no, okay. So there's I remember being in history classes and it being kind of taught that people believed the Earth was flat until the age of exploration.
Columbus, right.
And all that. But that is incorrect because people knew the Earth was round. In fact, the circumference, Aristophanes did the circumference, and people wouldn't knowingly go sail out just to discover the edge of the Earth. They knew they were going places. So that whole theory that people knew the Earth was flat before the age of exploration is
absolutely false.
Totally incorrect. Which I didn't learn, I think, until like college and I was like, oh, of course, duh, that makes complete sense. Like, why would people be going out in all these explorations that are dangerous and cost them their lives for just to fall off the edge of the fucking planet? Like, it doesn't make any fucking sense. So, you know, I mean, of course, there's always the people that think that kind of bullshit and want to buy into that alternate way of thought, but yes, so that's a historical, I would say, theory or hypothesis or whatever for you versus maybe a scientific. I mean, it's scientific, but it's more of a historical.
For sure, we'll have some fun history theories pop up.
But it also pulls into like the whole Aristophanes with the Earth being round, which you know, So
could it all be interconnected?
It is. Yes, exactly. All right. What is your craziest fact about the universe? And this was something. This was something that like I say this because this is my new current favorite fact, which will probably change eventually. All right. So I'll start while you think about it. Okay. So in prepping for the main episode, I came across a fact that said, well, not really for me, but for like you, your hair is covered in comet dust.
You still have hair on your body.
So
my hair's
like that.
It's covered with comet dust?
Yeah, so it's like every day all these meteors and shit happen on Earth.
Oh, yeah, but I don't go outside.
Yeah, it's like what 100 tons of material falls on the Earth every second or something.
All of that dust,
or every day,
all of it settles, right? And a lot of it, you know, some of it falls on your head.
Oh, we're also covered with like dust mites and shit, but.
Well, yeah, but I mean, it's so the dust mites on your hair are eating dust from comets, but you have comet dust.
Does that give them superpowers?
What?
I said, does that give them superpowers?
Yeah.
Okay, Ron has a fact in chat. Also, I'm still mind blown about this, and I have comet dust in my mouth. Ron says, craziest fact, a chicken will lay an egg a day until she has collected about a dozen eggs. Then she'll sit on them, and they all hatch the same day 3 weeks later. Wow, I didn't know chickens were so, like, punctual.
Yeah, and then we eat them.
Well, not the fertilized. Well, most people don't eat the fertilized ones.
No, but we did watch that show.
Or is that but is that the or is the ones that you get fresh from the hen fertilized, and that's what makes them, because you can store them not in the fridge.
All right, what's the one
maybe that makes them,
fridge? Because we watched that show. And
Brandon's getting so annoyed with this conversation right now, but he's thinking...
No, I'm okay. I'm thinking.
So they went in... All right, we watched the show. Was it...
The Liver King. We don't need to promote it any further. Well, actually, no. It was interesting. Yeah, but check it out.
Yeah, and it was very interesting. And they go into their pantry, this family's pantry.
Oh my God, it's cartons upon cartons of fertilized eggs from their chickens.
So many eggs.
Okay, so they are fertilized. I'm going to take your emojis, Ron, as fertilized instead of using the human English language in chat.
I was like, wait a minute, they're not in the refrigerator. They're just in the pantry.
That's why.
But that's what they do in Europe, right?
That's why fresh eggs are more delicious, is because they're baby animals.
Oh, God.
Baby animals taste better. Lamb, veal.
Yeah.
Whatever else is babies that we eat.
This is... Meanwhile, somebody on the right wing is watching this episode and going, see, I told you, they're baby killers. They eat babies.
Well, secret sauce. I don't know. I think I probably have had like fresh out of the hen hooter.
Out of the chicken. Straight out of the chicken.
Out of the hen tube. Just straight out of the hen tube. I don't know if I've ever had fresh eggs. I feel like, I know my mom has, because we had a neighbor that had chickens, and she would get some of her eggs, but that was after I had flew the coop, so to speak. I
do have to tell you, best duck I ever had in Beijing, eating Peking duck.
Peking duck.
ironically, in Beijing.
Yeah.
It was, oh, God, so good.
Yeah, Singapore, second best food I've ever had.
Also, in China, you get a lot of duck eggs. I had a lot of duck eggs for breakfast.
Ron, I knew this crazy fact number 2. There's only one hole on the business end of a chicken. That's for like all birds, right? Or most birds.
You know what
it's just
called?
one hole. Cloaca. Yeah. And they release white dielectric.
Nice
material.
I remember learning that like in biology class, and I was like, "What the fuck, really?"
Yeah, I mean, you know.
And then it was like, "Okay,
whatever."
I'll move on.
I mean, it's efficient.
Yeah.
I mean, they're flying around. They got shit to do. They got survival on the
literally.
Well, okay, but I'm talking birds in general.
Wait a minute, chickens don't fly, right?
No, they're not. They're not. They can kind of do a little bit of like a.
But then they dream about it, and they're like
a 5-second hover, maybe.
And they're like, "Hey, look, I'm flying, Mom."
I used to think when I was in kindergarten, I thought that I could fly because I like jumped off something, and I thought that I like hovered for a minute, and therefore I could fly. But hey, that's the mind of a 5-year-old.
Yeah, that is true. All right, is it David or Dave?
Oh, David. Well, favorite fact, total eclipses are super, super rare for planets. Like if we survive as a species and colonize the cosmos, let's hope not, I don't know, then Earth would be a tourist destination for them.
Yeah, so the moon's just the right distance from the Earth to appear the same size as the sun, happens to be in the exact same plane. So the fact that it happens is truly astronomical.
Hey,
yeah. Like for Mars, it's just a dot goes across the. Yeah. I mean, it's not a dot. It's not a dot at all. I mean, you do see
it's fear or it's death.
Well, you see this asteroid kind of thing go across the sun. For Jupiter though, you can be in a spot where you do have a total solar eclipse.
But is it where it's the perfect symmetry of the moon and the sun, or is it just Ganymede's big enough to cover the sun completely?
Well, it's not the like perfect symmetry of it. Right. It's not that.
That's what is rare. Is that?
Yeah, alignment. I mean that is rare. Yeah. But you can be, quote unquote, on the surface of Jupiter and
like I'm sure you can go out to Pluto and have Karen cover the sun pretty easily.
Oh well.
Because the sun itty bitty from out there.
Yeah.
Well, of course, yeah. They're also tidally locked. And so you can, if you're on one side of Pluto, you can see its moon all the time.
Oh, yeah.
But if you're on the other side,
it's
like, and you're a caveman,
you would never know.
Plutonian, you just don't know about it.
You would never know.
Right, you would never know.
Really quick, so I'm not going to do my usual favorite fact, because that's just my favorite fact.
Okay.
But the one, we've talked about this already a couple episodes ago, but the one that recently made me think, what? Is that 99% of all stars have already been made.
Oh,
99% of all stars that will ever exist have already been made. And that kind of broke me when I first learned about that.
And then the question is, what percentage of them have
how have we come to that conclusion? I mean, I'm sure legitimately.
I bet what it is you look at the the dust material,
the composition of the stars,
Milky Way,
and
the rate of decay, of star formation, but also the universe is 13.8 billion years old.
Yeah,
it's like how many people have lived on the Earth?
A lot.
A lot. It's like, has 99% of all the people who've lived on Earth lived on Earth already?
Hopefully it's not 100.
It depends how we go with climate change.
I mean, it's at least what, 90%? Because we did ask this question when Jehovah's Witnesses showed up at our door, which was, okay, how many people have lived on Earth? How many are now?
Right.
And so what
the math for the
that?
144,000.
Yeah, and so what are your odds of being the 144? And it turns out it's better than the
lottery.
The lottery, which made me upset. But anyway. was like, damn it. Come on, math.
It sounded really high. I was like, that's got to be like greater than the lottery, but no, the lottery was. I don't know, because you don't know. I don't know. I feel like statements, things like that are, like we don't know. Like we don't know enough. We don't have enough observation. We don't have enough eyes on the sky.
Well, no, but we can look at, galaxies, and you can see how much, dust is in them.
They have, and then you can extrapolate out how much star formation they have left. Okay,
and you can see what kind of star formation is happening in them, and you can make generalizations, and and from that you can say 99% of all stars have been. So it's not rooted in just it's just not rooted in conjecture.
Yeah. Okay, I get it now. I think I needed that kind of like that explanation. For it.
And so I mean, science is not wild statements that get made.
What?
In some cases, it is wild statements that get made. But then it has to be backed up. But not only does it have to be backed up, it's like within like CERN, it has to be backed up to a percentage.
Yeah.
And if it's not backed up to a percentage,
well, oh my God, Mom.
That is like so far.
It's on the egg talk. It's on the egg talk.
Oh no.
You've had lamb, Mom.
But anyway, so it's got to be backed up to a percentage.
Right,
Otherwise, it's just it's like 99.999% that it occurred and this is true. Otherwise, it's not really considered. There's there's doubt. And so remember, like when in science, it just takes one experiment to prove something wrong.
Right. That's the great thing about science.
A theory has to be right all the time.
Yeah.
A hypothesis has to be right all the time.
Like gravity.
Yeah.
So far, doing good. But
it just takes one. And so then scientists then have to wrestle with.
It just takes one bad apple.
Do we throw away? Do we throw away this theory, like with the Space Rocks guy with his series, or do we modify it, like with Newton and going in general theory of relativity, which then has to be modified in some way to be married with quantum, which means that we're going to throw general theory of relativity out. General theory of relativity is going to go away at some point. It's going to go away. As much as I love it.
Really?
Yeah, it's going to go away. Because at its heart, general theory of relativity is what we call a classical theory. It is just an extension of Newton, really is what it is. It doesn't take into account quantum physics, which quantum physics is...
I see now.
The universe actually operates quantum mechanically.
It's made of all those quantums.
Right, exactly, yeah. But there are certain things like the Heisenberg uncertainty principle. Schrodinger's equation, which is an interpretation of the universe, is fundamental to the universe. Is how the universe operates, and so general theory of relativity does not operate that way. So, as much as I love Einstein, as much as I love what he did with the general theory of relativity, well, just with relativity, it's incorrect. It's going to go away. Whatever this final picture is for like quantum mechanics, it at the end of the day will reduce to general theory of relativity or quantum mechanics or something like that. But it is general theory of relativity is going to go away.
Mr. Frodo has joined to say he agrees. He agrees with you. And I will smile and nod because it goes way above my pay grade with quantum physics.
Well, I mean, eventually we're going to have a quantum theory of gravity, and that's going to replace quantum mechanics, and it's also going to replace
gravity.
But also, if I can say that general theory of relativity is going to go away, our view of what quantum mechanics is today is also going to go away.
Oh
it's incomplete. So it's going to be replaced.
One of the things that annoyed me the most in the West Wing, I know, I left field here, is that they had a throwaway line where they're just sitting on a porch after an election saying, hey, they found the theory of everything. Cool. And then nothing changes after that.
I mean, yeah.
Yeah.
In the overall scheme of the world, but...
I look forward to the day where physics really does become nothing more than biology, where we are classifying
biologists
things.
Up in arms about that.
Yeah.
Well, bring it, bro.
Well, what about Bigfoot?
Oh.
What about Nessie?
Okay, all right.
Biologists still have work to do.
Question for the chat.
No.
This has not been Liz approved, so I'm going out on a limb here. So in July, Oak Ridge is going to host a Bigfoot festival.
I don't know if you should say the city we live in, but...
I have said where we live so many times, and you're just now saying that we shouldn't say.
Anyway. Yes, the Sasquatch Festival.
Yeah, it's called a Sasquatch.
But we don't want to... It's good for the community because it brings in tourism and stuff.
Right. So, we had this conversation last night before we went to a local theater, theatrical production, and which was actually pretty good.
It's very good.
And so... Should we go to the Bigfoot Festival?
Do we give money to
Bigfoot
enthusiasts?
Absolutely. They're harmless people.
Okay. All right. They're just a little nutty. They just like their things. They just got their kinks.
I guess we should find out, like, if we get kicked out, do we get our money back?
We're not going to get kicked out. It's not like if we're going to the Creation Museum, which we would 100% get kicked out of.
Oh, yeah. If Jane Goodall's on the Bigfoot train, then, might be worth,
Jane
might be a good time.
Goodall is on the
She's on the Bigfoot train. Yeah.
Maybe she'll be a speaker.
Oh, she is. Never mind. I'm not going to ageism. OG furries. I mean, look, it's great for the town, so we're happy to support it.
Chat has spoken.
Chat has spoken. We will go.
Yes. Okay.
We will go, and we will be positive participants of society and open-minded in honor of Jane Goodall.
We should do a live
Cosmos
No.
But we could, stay out there late and bring the telescope out.
Yeah, we actually did talk about
capture all these Bigfoot people.
And I may need to step away for a little bit just to give my Bigfoot some attention here because he's kind of going off.
Oh, Frodo.
Well, considering it's whatever time it is.
Yeah, we could call it.
Let's call it.
I mean, we've talked about some stuff. It's been fun. It's been good. We're all feeling a little drink mead. I don't. We'll give you a break because we also have to record some shots. Forgot about that. Yeah.
Yep.
We're no kink shaming. No kink shaming. No. Especially not the OGers.
Unless that's what they're into, then we can kink shame.
Yeah, if they want the kink shame, then you just gotta communicate your preferences and your pronouns, and we're there.
All right. Let's call it.
Okay.
What are we doing in 2 weeks?
It's your show. Oh, High in the Sky for June will be in 2 weeks, so I will already... Will we be in June already? Or almost in June?
I don't know.
Anyway, whatever.
I don't know how time works, but more of that, watch it sometime.
Check it out.
Wait a minute. Happy Volcano Day.
What?
Today's Volcano Day.
But happy Volcano Day, everybody. We will see you next time. Follow us on all the things at Cosmos with Cosmos. And we'll close it out. I'm glad you guys had fun. We had fun too. So
cheers.
Bye.
Resist.
All your reps.
And now I go to end everything. Goodbye, world. Goodbye.
Are we out?
Yeah, we're out.
All right.